Creating objects is anything but simple. You may feel overwhelmed with all the possibilities the latest C# offers. It all begins with the object's data, the state. The compiler is complaining already. There are a couple of non-nullable strings here, yet I have kept them uninitialized. That is where the class's constructor comes into the picture. The simplest of all constructors is the so-called parameterless constructor. Use it to set the state to whatever values you think would be fine. The constructor receives no parameters, so there's little to think about anyway. The compile time warning has gone. You will have known that if you define no constructors at all, the compiler will silently generate one for you. Still, it will differ from a common parameterless constructor. We call that a default constructor. The compiler will not be so diligent to instantiate contained objects. It will set every instance-level variable to its type's default. Reference types will be null, numeric values will be 0, bool will be false, and so on. Essentially, the runtime will zero out all bytes in the new object. This will really be what we need. The compile time warning is back. Say farewell to the default constructor. Welcome parameterized constructors. We need real data in the object's properties. We use the parameterized constructor for that purpose. Just ask for parameters one after another, then use the parameters to set the property values during construction. This is the parameterized constructor, your all-time best friend. Almost every class you write will have one of these. But what if there existed another way to construct the new object? For example, the display name of an author is usually just a combination of the first and last name. This is the overloaded constructor. Constructors follow similar overloading rules as the methods. There must be no collision between any two constructors on a class. There is no ambiguity here, but look what I have got. The second constructor is line-to-line copied from the first one, except for one line that differs. Here is how we fix that duplication. One constructor can delegate part or entire execution to another. Add a colon and then type this at the constructor's declaration. Then we pass all the parameters the other constructor requires. The first and the last names stay unchanged, but the display name is now a calculated value. It is perfectly fine to include an expression or even a call to a static method here. There is no code duplication anymore. This is the constructor that delegates execution to another constructor on the same class. Still, one element was missing throughout this entire demonstration: validation. This is the point when I need to introduce one important design rule. It stems from encapsulation, which tells that the object is managing its state privately while communicating with other objects via its public interface. The object is responsible for keeping its private state valid throughout its entire lifetime. The validity of objects is one of the pillars of object-oriented programming. Whatever the rules we establish for a valid author object, the constructor is where we validate the incoming values against those rules. Please note that object validation is not the same as domain validation. I can still pass pretty much anything as the person's name, and the object will make no objections. The constructor can only handle technical concerns, such as nulls, negative values, and similar. An object can only guarantee that there will never be an exception if we use its properties in the most obvious ways, such as dereferencing them or accessing the first letter of a name. Don't ask for more, and you will write a reasonably concise code that is reasonably safe from exceptions caused by bugs. The time is for you to learn the new trick. You can turn a specific constructor private. It would typically be the one with the most detailed list of parameters, often accepting primitive values. Public constructors would usually delegate to a single all-encompassing private constructor. The private constructor would contain all validation and assignment logic with no code repetition. What you see here is the delegating constructor. It helps bridge the gap between the caller and the internals of this class. So far you have seen how a class offers a constructor to other objects to create its instances. You can download the source code for this video from my Patreon page. Please note that every registered patron is helping hundreds of other fellow programmers watch all videos on my channel for free. By becoming a patron, you will get access to the source code for all the videos on my channel, Discord server, and more. The links are in the description. We will now investigate what the class looks like to its inheritors. Suppose that there is a derived class that models a subset of authors. Here is the new constructor. It only accepts the full name along with the birth year. The compiler is complaining already. Some base constructor must execute first, so the derived constructor can safely access the inherited data. As I wrote this constructor, it will implicitly call the parameterless constructor in the base class. But such a constructor does not exist, hence the compile time error. We must delegate to an existing constructor in the base class. However, this is not the right way. With the this keyword, we delegate to a constructor on this class. We need to delegate to the base class instead, so we use the base keyword. Then come the parameters. I could isolate the last occurrence of a space character in the full name and take everything that precedes it as the first name. Then take everything beyond the last space as the last name. The remaining two parameters are straightforward. The compile time error remains though. The parameters are correct, but the constructor is private. No other class, including the derived ones, can access this constructor. The solution is to turn the base constructor protected. Even though you might be tempted to believe that object-oriented programming encourages derivation, it is not so. You need to prepare the base class for derivation, which may include implementing a protected constructor. Anyway, the derived class should work fine now. I'm adding the override of toString so we can see the actual data. Let's create some objects at last. Here we see Martin Fowler, known for the refactoring book. This object is an instance of the base class and uses its public constructor. Late Dennis Ritchie will take the object of the derived class. He is known for the C programming language book and for the invention of the C itself. The derived class should be able to split this name into components. However, I do expect trouble with Fred Brooks. Mr. Brooks is well known for the Mythical Man month, but it is not widely known that his full name includes the junior suffix. Unfortunately, my data model does not support name suffixes. And the last example I want to try is Leonardo Pisano, whom we know as Fibonacci. His Liber Abaci has changed mathematics in the Western world forever. He will also cause an earthquake in my demo. I must prevent total disaster by handling the imminent exception. Let me run the demo at last. The first and the second objects were just fine. The simple author class has split Dennis Ritchie's name just right. It has failed miserably on Fred Brooks's name though, but Fibonacci... There was an exception in an attempt to split the string that doesn't contain any white space. This completes the coverage of regular constructors, so to speak. I will now raise the bar and show you a few types of a different breed. What would change if this all-encompassing constructor were public? C# has something to offer in a case like this. Suddenly, this constructor becomes more important than any other in this class. You can turn it into a primary constructor. Starting with C#12, you can define so-called class parameters. Just list the parameters as if the class name were also a constructor. In fact, the compiler will generate a constructor with these parameters for us. These values are now available through the entire class's body, like class fields. It is typical, however, to only use them to initialize the properties. Still, we must validate primitive values. I will apply validation on the assignment. Fluent or inline validation is common in property initialization. On rare occasions, you will need to extract a static method that either returns the valid value or throws. Nevertheless, I have assigned all properties to validated values now, so my object will be as valid as it ever was. I can delete this traditional implementation and leave the primary constructor in its place. You can often condense property declaration, validation, and assignment into one line. It is especially true with object parameters, which you don't validate anyway. All other constructors must delegate directly or indirectly to the primary constructor. In this case, it is a compile time error not to delegate from a constructor. How does that reflect on derived classes? Let me implement a primary constructor on the simple author class too. It would receive the full name and the birth year, as it used to. Then call the base constructor as part of the derivation. It was simple after all. The class has become visibly shorter this way. On the other hand, no consumer will ever notice the difference. Primary constructors are just a class implementation tool and nothing more. There is one more constructor kind I want to show you in this video. It differs from everything you have seen so far. We call it a copy constructor, and it is irreplaceable in one particular use case. The implementation first. The copy constructor takes the data content of another instance to populate this instance's state. Please be aware that this constructor has access to all the content of the other instance. That includes any private fields and properties too. I can do the same in the derived class. Just poke out the components and pass them on to the constructor. How do we use copy constructors, and more importantly, why do we need them? You would take an existing instance and create another one with the same content. It goes similarly with objects of the derived class. Only make sure to use the copy constructor on the derived class, or otherwise you might lose any values that derived class appends to what it has inherited. I have already said there is a specific use case for copy constructors. So, what is it? It is useful when you pass a mutable object to an external method. You might fear that the method could modify your object, causing erratic behavior on your end. You can avoid unintended changes to your object by copying it before passing it on to another method. That completes the coverage of 10 different kinds of constructors you will use in your code. But there is more for you to learn. There are static constructors, initializers, factory methods, and smart constructors. You can then move on to learning about init-only setters, required properties, and constructors that initialize required properties. You better master the concepts of initializing objects for your own good.